gives you the red light. Okay, we're recording. You have the green light there. And I'm going to show content here.
Okay. And the speaker's actually.
Okay, and that's good to go there. And you push there to end up, okay? All right, you got it.
Okay. All set? All right, so once again, because we took a little time on the exercises yesterday, there are a couple things that I neglected to get back to tell you, so I just want to point them out real quickly. The course today, first of all, is not going to take you that long. It's a pretty simple course. We'll go over it again when we get to the other room. I'm actually going to hand out the maps in advance and go over a couple of things on the map first. But it should only take you about 20 minutes or so to do that course. So we have a little bit of time here to go over things. First thing was we really didn't talk about measuring distance, right? Other than what I've been trying to encourage you to do is do that micro-navigating, right? Using that thumb and checking off the collecting features as you go. And when you do that, and if you could do that all the time, you really don't need to have any other measure of distance because you know where you are on the map, right? Well, in some cases that may not work, right? You could be doing something like you're doing a night ring or something like that where you can't see the features. And particularly if you're going from an attack point to a destination and there might be similar features out there, it might be important to be more precise on how you do it. So the way that we do this is by pace counting, right? Has anybody used pace counting? And most of you guys, have you used it in your orienteering before? Not at all. Okay. So you're probably doing kind of the right thing, right? I mean, if you're getting by just looking at the map and the features, that's the best thing to depend on. So, and what the more advanced people learn to do is to visually, because they are checking things off every 100 to 200 meters, they can kind of train themselves to just look at something very quickly and it'll be 100 meters out there and they know what 100 meters is, right? And or if it's 50 meters, it's half that distance. And so you can kind of do that without having to pace count. But at some point you should understand how to do it. You should understand what your pace count is in case you have to find it. Like if you're having trouble, you got a little lost and you've got to be more precise about trying to get on a particular track, then you want to probably go back and do the pace counting. So pace counting, what we really mean is every other footfall, right, when you do this. And what I have set up out there, you're not going to need it for this course today, but out behind the stadium I have a couple orange cones, one basically at either end of the football field, plus a little extra, and that's 100 meters, okay? I've tried to do this different ways, and I'll tell you, I always come back to know what your pace count is for 100 meters, and then figure out what a centimeter is on the map, because that always works on all maps, and it's easy to do the math. Okay. So pace counting, when you get more advanced than if you're a runner, right? I mean, pace counting, when you go out and do that course, what you want to do is you don't want to take giant steps. You want to take a normal walking pace across there and count it out and then write down the number. And what the number should be for 100 meters, I mean, if you're kind of a short person versus a tall person, you're going to get a different answer, right? So you're going to a short person is going to have more steps and the tall person is going to have fewer steps. For me, mine comes out to about 60. So when you do this experiment, if you're shorter, it might be more on the order of 70-ish. Taller, it might be 50, 52, something like that. Okay, so that's kind of ballpark the answer you should get when you do the experiment. But when you are starting to run, right, that changes your pace count. And there's ways to adapt to that. But that's more of a learning thing. That's a little bit more advanced. So we're not going to go into that. So again, after the course is done, if there's a few minutes, you can go do that. And that way you know what it is. Just remember that number. Okay? So we talk about the scale on the map, right? So if we are counting out a centimeter, and by the way, when you look at the maps, I'll encourage you to see if you can find a centimeter on the scale. There's usually something that's a centimeter long. And it's real handy if you've got a fingernail or something like that, like my little pinky is just about a centimeter, and you can check it on that map. And then that way you can just put it on the map anywhere and count off whatever a centimeter is worth. And so here's kind of a table that sort of gives you the answer. But basically, if you have a 1 to 10,000 map, so what's a centimeter? How many meters is a centimeter? 1/100th, right? 0.01. This is a terrible marker. 0.01 meters, right? And to find out what that represents in the real world, you multiply by the scale number. So you're going to multiply that by 10,000, right? Which is a nice, easy number, because all I'm going to do is move digits. 1, 2, 3. Let's see, I did that right? 1, 2, 3, 4. Should be 100 meters. 0.01. So yeah, 4 digits. So 100 meters. So 1 centimeter is 100 meters, right? And if it's a 1 to 12.5, that's pretty easy math too, right? It's basically that times 1.25 or 125 meters. This is on the table. So when you get this map of the campus, it's a completely different scale, right? It's going to be 1 to 2,000. So 1 centimeter, what's that going to be? 0.01 meters on a 1 to 2,000. It's going to be bigger than 100 or less than 100? It should be less than 100, right? Because it's a smaller scale multiplier. It's going to be 20 meters. And you'll see that when you look at the scale on there, okay? All right. Any other questions on that? Again, I encourage you guys to really focus more on the map and using collecting features as much as you can, but it is a very handy technique. I think I just went through this example. Compass bearings, I was going to go over compass bearings in quite a bit of detail, but I'll tell you, I think where you guys are at right now, if I spend a lot of time on it, I think it might confuse you a little bit more than it's going to help you. So I really think, but you guys go through this exercise, maybe do the thing on Saturday, just using it without the bearings and get comfortable with that. Then I think we'll save that for more advanced training a little bit later on. Where it comes in useful is for greater precision. Right? And this helps particularly when you get to more advanced things like trying to relocate or triangulate a position. It's handier to do it. It's also handier, well, what it does, another advantage for you is if you set the bearing, you can go on a bearing decoupled from looking at the map, right? But that's exactly the opposite of what I've been telling you to do, right? You really want to focus on it, on the map and not trying to keep that magnetic needle in the little box, which is what the bearing will do for you. So like I said, I think I'll reserve actually doing that for a more advanced. It's a lot easier to do or better to do out in the field. So someday when we have some time, maybe we can go out and do a course, and then we can do some more precise navigation with that. You know, as a reference, YouTube, I mean, if you're really interested, you could do it. Also, the method I showed you of having the map out in front of you and orienting down there and using what we call the rough compass, just the needle, it's real easy to take that one step further if you really want the bearing and rotate the housing around so that what they call the meridian lines, if you remember what those are on the dial, and the north end of the meridian line also points to magnetic north, then that will give you the bearing. All right? And when you do that, since the map's already oriented, basically that little orienting arrow, the little box, will line up pretty closely to where the magnetic needle is because you've already got the map oriented. Okay? And I think that was about all I really wanted to cover here. While I have you here before we get going out in the field, let's see, anything to notes for Saturday? So how many people are going on Saturday, by the way?
Most likely.
Most likely? Okay. All right, so that's going to be a Scoro. Have you guys done the Scoro before?
Yeah. What's that?
Scoro is where you can go to, well, have you done the Orienteering before? They've all been scoring.
Oh, yeah, it's all done.
Yeah. Okay, do you guys plan a route before you go, or you just go?
Yeah, when I get some map.
You get 5 minutes to use the map.
Oh, okay, so you plan before you go. All right, that's fine. That was my only real tip, was to do that. Again, a couple other tips on the map. Quiet, please. A couple other tips on the map. Remember, those magnetic north lines are usually printed at a certain distance between them. So that's going to be, since we know what the map looks like, it's 500 meters, right? So if you guys are trying to estimate distances and trying to figure out where it's going, you can just look at it instantly. And like I said, figure out what a little finger is. If you can have a ring finger or something that's a centimeter, it's real easy to put on the map and be able to measure distance that way. And other than that, I think what we can do is we could just go back over to the other building and then go over the course that we're going to do today. Any questions on any of this?
No, sir.
Okay, great, thanks.